Hey everyone, so in this lecture, let's go and discuss the basic configuration that needs to be performed on your Palo Alto Next Gen Firewall. So what we have here is, our PAFW1 sitting on the data center is currently powered on, and you can see that we have got a LAN user, which is the Windows client over here, running with an IP address of 10.1.1.10. It is running and it needs a default gateway which is pointed to the firewall right here, right? So we have to go ahead and assign the respective IP address on this particular client device, which is the Win client, and also we need to do some configuration on the Palo Alto Firewall 1, basically the inside interface, which is Ethernet 1/1, its IP address. We need to go ahead and configure Ethernet 1/1 its IP address. We need to go and configure the Ethernet 1/2, which is facing the outside world. We have to go and configure its IP address, right? And we will set up this edge router, which is connecting to our private WAN network and the outside world to the internet. So first of all, before we go ahead and configure the Palo Alto firewall with this basic IP and the basic routing towards the edge router and so on and so forth, let's go ahead and configure the edge router first. Okay, so let's go ahead and open the console for the edge router. Just give it a sec. Here we go. So it's sitting on the default condition. So what we have is the interface G0/0. It is facing towards that 123.110 subnet, from where the IP address should be 123.111, and the G0/1 is facing towards the towards my management network, basically, or towards my WAN router, which is running on 192.168.1. Series network, okay, which is having represented as the public internet space. So just give it a sec. So we go to the global config mode and we define the host name, say it is edge router, and then we define some basic commands where we say line console 0, so it's my Cisco router, logging synchronous executable timeout as 00, no IP domain lookup, and we go ahead and configure the couple of interface with its IP address. So G00, no shut. The IP address as per the plan is 123.111 n/24. Oops, sorry for that, I missed one there. And interface G0/1, no shut. Its IP address is on that 192.168 series, so let's say it's 1.100, and let's say this is the mask it has of /24, and I need a default route which is pointed towards the gateway 192.168.1.1, which is my WAN router, or through the ISP, you can think, right? And we would need to access, ensure that this particular outside private WAN subnet, should have access to the world of internet. So 123.110 should have access to the world of internet. So any IP from this particular subnet, if it is trying to route to this edge router and go outside, ensure that it has got internet access. So for that, we will actually place this particular 123 subnet in an access list component. Okay, so this 123.110 should go inside this access list component, and this ACL will be configured in a dynamic path configuration, right? So keeping that in mind, let's go ahead and configure. Just a second. Okay, so let's say we write down the access list, standard ACL, where I'm permitting this private WAN block 123.110.000.255 with the wildcard mask, and then I create that NAT, so IP NAT inside source list, so my ACL address is specified in the ACL value of 10. So IPNet inside source list, so which in turn will have the interface which is pointed to the outside interface, which is G0/1 with the keyword of overload. And on my inside interface, I should enable NAT as IPNet inside, so the NAT engine will get turned on the inside port. Give it a sec for it to get initialized. And on the outside interface, which is G0/1, I should have IPNet outside feature turned on. Okay, with that in mind, if you see do show IP interface brief, so I can see I've got my couple of IPs over there as expected. And if I see do show IP route, I should have a default route which is pointed towards my gateway. A static default route is right configured here, and I should be able to ping to the world of internet. So ping to public Google DNS should work out. Give it a second. Right, this is working fine. And also I should be able to ping the world of internet with source of my private WAN IP 123.111. Here we go. So this 123.110/24 network right now have an access to the world of internet. So let's save this configuration. All right. Okay. So once this is done, so now your job is to go ahead and configure the Windows client and the Palo Alto firewall sitting here with the basic IP addresses and its configuration. So the final goal is to allow this particular Windows client device to be able to reach to the world of internet. Right? So the final outcome should be make sure that whenever it wants to access any internet services, it should be able to route the traffic to the firewall. From the firewall, the traffic should be routed to the respective gateway, and from there the traffic should be allowed to reach the world of internet. So for doing so, I should have the respective inside and the outside IP addresses configured properly. I should have the routing configuration done, so the firewall should point a default route from this edge router, so this IP address should act as the default gateway for the firewall. And then I should have the NAT configured on the firewall so that the 10.110/24 LAN subnet should be allowed to reach to the world of internet. Okay, so right now this particular private subnet 10.110/24 does not have any internet access, right? But your private WAN network, which is 123 series, it has got internet access. So ensure that we will do a dynamic pat on this particular outside interface of the firewall, which is Ethernet 1/2. So this particular user which is sitting on 10.110/24 subnet, whenever this user is trying to reach from this particular subnet, okay, anywhere to the world of internet, make sure that it should be natted, or we should do something called as dynamic pat or port address translation on this outside interface IP. So we should do a source NAT so that this particular source IP should be natted on the outside interface IP, and then the traffic will be allowed to go outside. All right, so with that in mind, I hope this is clear right now. So let's go ahead and check the configuration of your Win 10 client PC. So if I look into the Windows 10 client over here, supply the password, . Okay, so I want to check its IP address configuration. So click on this change adapter settings, uh, click on my local area connection right here, and I see the properties, TCP IP v4. See the properties. What I've done is I've statically allocated this IP address 10.1.1.10, the mask of /24, and the default gateway is pointed to 10.1.1.2.0.1, and see the public DNS IP that I've fed here as preferred, and the alternate DNS server of Google, which is 8888 and 422. Okay, so and this default gateway is basically pointed to the inside interface IP of the PA firewall 1, which is Ethernet 1/1 IP, which should run on 10.1.1.2.0.1. Okay, so with that in mind, I click on OK, close it. Yeah, so now the point is, if I go to the command prompt and try reaching my gateway, which is 10.1.1.2.0.1, it should not reach, because as of now the PAFW1 is not yet configured with any IP address setting. That is the first thing, and of course, I'll not be able to reach to anywhere in the world of internet as well. Okay, that's easily understandable. All right, so so my IPs are configured on the client. Now it's time to hover to your PAVM, okay, and go ahead and configure the interfaces on the PAVM. So let's make a note of it. So your ETH1/1 is inside, running on 10.1.1.2.0.1, and ETH1/2 is outside or sitting on the untrusted zone, running on 123.1.1.2.0.1. Okay, so to do that, we'll first click on the network tab over here in my PAVM, and we will click on the interface from the left, the interface option from the left, and we'll select Ethernet 1/1, so which is going to be part of your inside interface. So I say that this is my inside interface. I select the interface type as layer 3. It's a layer 3 interface, and netflow profile, if you have it, you can choose that. As of now, I don't have a netflow profile, so I select that as none, and you can assign this interface to a virtual router. The virtual router is just like VRF of your Cisco routers, or in Palo Alto term we call that as VSys, virtual systems, right? So you can create many virtual systems, or you can say you can segment the routing table into smaller individual routing tables, right? And in each smaller routing tables you can assign the respective interfaces. Okay, so this Ethernet 1/1 can be part of one default virtual router, or whatever virtual router that you can create. So we'll discuss that things later, but right now we will place to the default virtual router that we have already. So my interface is part of the default virtual router, and next is your security zone. So make sure this interface should belong to the inside or the trusted security zone. So my zone is not yet configured, so we click on this new zone, and then we go ahead and name it. So my zone name is say trust. You can go ahead and configure the log setting, where you can go ahead and configure a log forwarding profile if you want. Okay, so where you can have an external log collector or assist log collector to take your logs. So we'll do that later. As of now, keep that as none. Type is layer 3 because already you have chosen that. You can also select interfaces over here. While configuring zones, you can add some other interfaces to be part of this trusted zone by clicking on this add button. You can have other features like on this particular zone configuration, you can enable zone protection profile, pre-NAT identification services with respect to user ID, device ID, etc. User identification ACO, device ID ACO, which contains the include list and the exclude list. So we'll discuss those things down the line, but yeah, as of now, just make sure that the interface should be part of the trusted zone. And we have done this, and click on OK. And yep, after this select the IPv4. So make sure that the inside interface should be part of IPv4 address. I want to assign this aesthetically. If you have the device enabled with this license, specific license, if you have, then you can enable SD-WAN based on the licensing type. You can enable SD-WAN services. So yep, so select IPv4, select type aesthetic, click on this add button, and you can define a new address object. We'll discuss object later again, but as of now you can just select an IP address on that particular interface that you want to apply, which is 10.1.1.201 /24. That's the IP. And yep, so IPv6, if you want, you can choose that. SD-WAN, again, based on the licensing type, you can do that. Click on the advanced, where you can set your link speed, link duplex, and the link state. You can change that. Other info, like you can modify, or you can work with ARP entries, ND entries, LLDP, DDNS, etc. Management profile. Now this is something where you want what are the management services you want to allow on this particular inside port. Now think in cautious way before you apply that. So it's my interface, so let's say I want to, for testing purpose, this is my lab environment. Let's say I create a management profile where I allow certain services for my testing purpose: HTTP, HTTPS, Telnet, SSH, and SIP ping. Okay, later on we'll enable other services. So yep, click on OK there. So my management profile has been called into that particular respective interface E1/1. Alright, so with that in mind, click on OK. You can do adjust TCP MSS and all those things later. Yeah, so my interface is ready. Likewise, let's go ahead and create the Ethernet 1/2 outside port. So that would be my outside interface. Type should be layer 3. Virtual router, let's go ahead and select default. Security zone, let's go ahead and create a new zone. So E1/2 is on the untrusted or the outside zone. So just name it as untrust, as layer 3. Let's let the other configuration be at its default stage as of now. IPv4 static IP, let's click on add. The IP is 123.1.1.123.1.1.201/24. Here we go. Nothing for VC, nothing for SD-WAN. Click on the advanced. You can select the management profile. It's my lab environment, so I am allowing those management profile services on the outside port as well, but in production environment you will generally not allow HTTPS or SSH telnet on this outside port, right? Just for labbing it up, I'm doing it. That's okay. Click on OK there. So both of your interfaces are right now configured. Okay, so you can check what management profile you have added here, what is the IP addresses the port has, to which virtual router it belongs to. Tag we'll discuss later. VLAN or virtual WAR, those things we'll discuss later. It's part of the security zone, which is trusted and untrusted respectively, right? And you can see the comments that you have, or the descriptions that you have given. Alright, so as of now, if you look back in your design, so your ETH1/1 and your ETH1/2 is configured with the respective IP, with the respective zones. Now your job is to go ahead and configure a static route on this particular Palo Alto firewall, a static default route which will point towards the edge router that should act as the default gateway for the PA firewall. Okay, so let's go ahead and do that. So let's go to the PA firewall and let's go to my virtual routers over here. Under the network on the left you'll have virtual routers. So you've got the default virtual router, select that, where both the interface are part of it, and you have all the routing configurations which is part of this virtual router profile, right? So click on static routes. Let's add a static route over here. This is going to be named as, let's say, default route, and my destination is 0.0.0.0/0. My interface that I have over here is going to be the outside interface E1/2, and the IP address is the edge router IP, which is 123.111. Rest everything can be sitting as the default. So I'm saying that, hey, FW1, if you have any default route to follow, this is the next stop IP address, which is the edge router IP, and this is the exit interface. That's your untrust interface or outside interface, which should be used to point to the default route. All right, so all the other advanced things, like you can add a VFD profile, you can do some sort of path monitoring, like add SLAs to your default routing to the next stop IP address that you have configured over here as well. So anyway, click on OK as of now, and let's click on OK there. So I have got a default route. If you can see on the right side, more runtime status right here on the extreme right of your page, you can see that under routing, since you have not committed, so the default route will not appear here. Once my commit has been configured, I can see the default route taking place right here. Okay, so let's go ahead and do a commit. So let's click on commit, and you can see that I have got multiple options of doing commit. So right now it is there in the candidate config. I want to make it to my running config. So if you say commit all changes, or commit changes made by one admin, so this is very important things to understand. So there can be multiple administrators working on this particular Palo Alto firewall. Right now, if you have the rights to commit the changes, which in turn accounting the changes for other administrators as well, so you can click on commit all changes and ensure that you do that. You can also preview the changes over here. Okay, what changes that you are going to configure. Click on change summary, you can see which is the owner who has done those changes, who are the previous owners, what object that were actually been configured and changed. Yeah, so it is part of the candidate config that will move to the running config. There we go. It can validate the commit, right? So I will discuss that later down the line. Hold on for this. So what happens right now is, let us click on commit. Okay, so it basically goes with a three-phase process. Phase 1 is where it creates some object IDs. Phase 2 where it pushes those object IDs to the respective daemons or the respective services. Once those services are getting enabled and getting successfully pushed by those object IDs, then at phase 3 no problem occurs generally, and the commit becomes successful, right? So it's a three-stage process. It may take some sort of time. So while the time commit is happening, you can actually watch it, or you can see the details if you find anything over here, or you can close this particular commit section also, and you can see it later whenever you want. So if I close it, just give it a sec. Okay. All right, so if I select on this task over here, I can see that my commit function is running, right? And the commit has been completed. Okay, so let's click on close. So it is there under that particular task on the bottom right of your screen. Okay, so the commit has been taken place. So now if you look at the virtual router, the default virtual router that we have over here, and if you look on the more runtime stats, you can see that what are the routing informations you have. You have got the default route, you have got the connected routes, and so on and so forth, right? The respective next hop, the respective metric, the interfaces through which these routes are connected, etc., etc. Okay, so as of now, my routing is in place. My my IPs are configured. as of now. So now the next turn will be to configure a security policy and then configuring the source NAT policy for this DC subnet, so that the DC subnet user can go ahead and access the world of internet. Okay. Okay, so now let's go ahead and create the security policy rules to allow the traffic from your inside to the outside zone, because by default if you look into the policies tab, okay, so you'll have a couple of security policies which is there by default, which is going to be your intra-zone and your inter-zone policy. Just give it a sec. Just refresh the page a bit. Okay, so let's create this particular rule to allow the traffic from my trust to my trust zone. So click on add. Let's say this is going to be my internet access policy, trust to untrust. Okay. You can define tags we'll discuss later. You can just go ahead and define the original packet. So define the original zone from where the traffic will arrive on this firewall. So the traffic will be sourced from the trust zone. The destination zone the packet will leave is the untrust zone. The destination interface should be Ethernet 1/2, right? The service is any service, right? And source address, you can define the LAN address which you have. So in my case it is 10.1.1.0/24 subnet. So let's go ahead and define that. So either you can define the subnet like this, right, or you can call this particular subnet in an address group. That is the better way to, or an address object, by the way. So let's say I create a address object called as LAN 10.1.1.0 to refer. This is my LAN data center, my LAN of data center, which is 10.1.1.0 as a description. The type could be, there can be multiple type, which is IPNet mask, IP range, IP wildcard mask, FQDN, etc. So let's say I select IPNet mask, and the network address is 10.1.1.0/24. Okay, so you can allocate some tags. So tags we'll discuss later. Yeah, so this is how you create an address object and define the respective subnet to that address object, and click on OK. Once this is done, the destination address where the traffic can reach, let's say it's any, and then you can define the transited packet. So I'll discuss regarding the transition packets. As of now, this is the security zone that you have configured. I mean the security policy. Oh, I'm sorry. So basically you are on the wrong term. So basically you are configuring the NAT policy first. So let's do that later. Okay, beg your pardon. So we need to click on policy and we need to select the security policy tab. So I was onto my NAT policy, which I have not seen it. So when you select the security policy tab, so you see that there are a couple of policies that has been there by default. One is intra-zone and one is inter-zone. So intra-zone policy is anyway it is allowed. So within the zone the traffic is allowed, but between the zones the traffic is denied. Okay, so let's go ahead and recreate the security policy for allowing the trusted services. So let's say the security policy is for internet access. Trust to, now this is, let's say it will not take much characters, so internet access is fine. Rule type, keep it universal, that's fine. So it is internet access trust to untrust, like that you can define in the description. Tags we'll discuss later. As I've told you, define the source zone. It's going to be my trusted zone. Source address is that LAN object which I've created. Okay, you can also call the user ID and the device profile. So only that user ID having that respective device profile will be listed along with this particular source address. Okay, You can also do that, refer that. Click on destination tab. So destination zone should be that untrusted zone. Destination address and destination device is any as of now. So application, I'm keeping this as any application. Okay, but if you want, you can add the respective application of your choice. Okay, as of now I'm letting the user to access the user from the 10.1.1.0/24 subnet to access any application, right? Having any application default service or default URL categories on that application ports. Action when you select, so there are multiple actions that you can take: deny, allow, drop, reset. Everything has got its individual functions. So as of now I click on allow. Under profile type, you have got profiles. So these are your different layers of profiles that you can attach to your security policy rules, like antivirus profile, anti-spyware profile, vulnerability protection profile, etc., etc., URL filtering profile. So yeah, those things are again in my advanced classes I will discuss. As of now, profile, let's say it's none. Log setting, generally there are multiple. You can see that log at session start, log at session end. So whenever the traffic is found a match or hitting this particular rule, so the log will be taking place, right? Or you can also create a log forwarding profile where you can have an external syslog server or a log collector to capture those logs. So generally we keep it at log at session end. And likewise you can also do a scheduling. So if you want that this profile should be activated at a particular period of time on a particular day or during some range of dates for a range of time, you can do that. Likewise you can apply QoS markings on that particular rules as well. Okay, disable server response disable server response inspection, and if you want you can also check that. Yep, so all those things, let us keep it as default. Click on OK right now. Looks good. So you've got your policy on the first rule. So the policies read from top to bottom and from left to right. Okay, so ensure that first come, it's like first come first serve. So always make sure that the most granular policies should be written on the top of the list. It's like an access control list, as you have read earlier or you've seen earlier. Alright, so my security policy is configured. Likewise we'll go ahead and now configure the NAT policy. So as I've told you that this particular inside subnet should be dynamically patted, or dynamic NAT should be applied on this outside interface. So should have a port address translation done for this, right? So the idea is whenever this particular user is trying to access your internet, okay, so how my NAT traffic, how the traffic will look like with NAT is this. So this is the user which is having an IP of 10.1.1.10. It is trying to reach, let us say, anywhere in the world of internet, say 9.9.9.9. now we'll have this is my source IP will have a random port number, say 1234, and say this is the destination IP where the user is trying to reach. Its port number is, say, on port number 80, right? So this is basically called as the socket, right? So this is generally called as the source source socket, right? Source socket and the destination socket. So that's your source socket and that's your destination socket. Okay, so combination of IP and the port number. Okay, so now this is your like pre-net. So once the traffic reaches the gateway, so ensure that the firewall, I will talk about the packet flow and all those things later, but yeah, the firewall should do NAT. It should have the routing table known to reach. So the firewall says that, hey, you want to reach 9999. I don't have a specific match for 9999, but hey, I've got a default route which is pointed towards my outside interface, so I can allow the traffic to leave that outside port and hit my next hop IP address right here, and from there it is the responsibility of that next hop device for the packet to be routed, right? So this is done, but NAT plays a very vital role because this is a private subnet. It does not have internet access, right? But you have allowed this public subnet right here to be part of the internet access. So we have done this. We have done the NAT configuration on my edge router. You have seen that earlier, right? So this particular outside 123.110, the private WAN block has got internet access. So we need to ensure that we should go with this concept of source NAT, right? Source NAT. So we've got two types, source NAT and destination NAT. We'll discuss that again later, but ensure that this source IP, which is a private IP address, has to be translated, right? So we should do a source NAT on this particular let's say on the outside IP address of this firewall. So now after the source NAT, what should happen is the traffic will look like this. So it will be 123. The source IP will be translated to 123.1.1.201 with whatever port number that is available. Let's say it is 5454, right, as an example, or might be it will remain the same. Depends, right, on whatever it's available. Or if some session is already using 1234, then it will translate it. If it is found as free, then it might keep this as the port number as 1234 itself, and the destination will not be untranslated. It will be on port number 80. Okay, yeah. So likewise, the reverse traffic will also have the same policy, right? When the traffic re-enters, it will also be untranslated, and then the traffic will be given back to the user. Yeah. So this is very important. So ensure that we have to perform this NAT operation on this PFW1. So let's go ahead and clear this particular stuff. Okay. Let's go ahead and configure your PFW1 for the NAT to happen. So let's go to the policy, select the NAT, and let's click on the add button, add the NAT policy rule. So this is for my internet access NAT. Okay, we can give a description. So this is my SNAT for DC LAN 10.1.1.0 subnet. Okay, define a tag if you want. NAT type is IPv4, but you can see there are different types of NAT supported: NAT 64, NPTv6, etc. Yeah. So as of now, let's go to the next tab. There is original packet. The source zone should be your trusted zone. The packet will arrive from. The destination zone is that untrusted zone. The destination interface where the traffic will leave is Ethernet1/2. Define the service. Source address is that 10.1.1.0/24 address block. Destination address is any. Okay, let's keep that. And the translated packet, when you look for, so you can see that we have two types. One is source address translation, one is destination address translation. So we are looking for source address translation over here, and we have different types: dynamic IPN port, persistent dynamic IPN port, dynamic IP, static IP, etc. So we look for dynamic IPN port. Okay, so we look for translated address. Okay, we look for interface address over here, and the interface is basically Ethernet1/2 on which my NAT will take place. We normally call this as a port address translation or PAT, and this is the interface IP address on which my PAT will take place. Okay, yeah, and then we leave the destination address translation because we're not touching that. Click on OK, and ensure that you go ahead and make sure you commit those changes. Right, so let the commit process runs. Okay, okay, so you can see that the commit has been configured successfully. So this commit is done. Let's click on close, and now what you can do is let's go back to the topology here, and let's access the Win client. So from the Win client, I should be able to let's say ping to my gateway, which was not accessible earlier. So now 10.1.1.201, this is reachable. That's a good news. and also let me try to reach the world of internet, and it is reachable, right? So what you can do is now you can open up your some favorite browser right here. Let's say I open up Chrome and I try to access some sort of web pages. I close this. So let's say I try to open YouTube as an example, right? And you can see the page is getting loaded. It's a virtual machine, so ensure that it might have some sort of lags and delays. So you can see the page is getting loaded. You can try opening other websites, cnn.com, etc. Yeah, so you've got an internet access, right? So this is working fine. Just it is a bit of delay because of the virtual machine and its CPU. Alright, so the user has got internet access. Now you can see you have sent some traffic through the particular firewall, right? And the firewall is allowing the traffic based on the security policy rule because of the NAT rule that you have configured. Now if you hit back to the firewall, if you look back to the monitor tab, right, or let's say you are in the policy tab, and on the policy tab you have got this security policy, right, rule that you have created, and on the right hand side you can see that there is a tab called as hit count, right? And you can see that there is a hit count of 206. If you refresh it, there's hit count of some 262. Hit count is there, right? If you want, you can reset that hit count to be 0, and then you can send some packets and see if this count is rising or not. Okay, and that way you can troubleshoot that, hey, if this policy is getting matched against your traffic or not. Okay, likewise, if you click on this NAT policy that you have configured, you have some hit count over here. That means the traffic has been gone through this particular NAT policy and the NAT engine. And likewise, if you click on this monitor tab, so on the monitor tab you have got different traffic logs that you see over here, and also in the traffic log you can see what is the timestamps, what is the zones the traffic was originated and the destined for, the source IP of the traffic, the destination IP of the traffic, the ports, the destination port, the application the traffic was hitting on, whether the rule was allowed or denied, which rule it followed, session and reason, how much amount of bytes the traffic has been taking, and so on and so forth, right? So you have got multiple things. If you click on that magnifying glass, you can also see the rules in a detailed way. So like you can see that, hey, this particular first log that I see, the traffic log, is having a session ID of 131. Action is allowed. You can see the source info, the destination info, the zones, the ports, etc., the source port number 49221, the country, origin, etc., etc., right? So you can see all the details over here. Likewise, you have got a session browser, so you can see the current active session that is running on this particular through this particular firewall. And likewise, if you can expand this, you can see those in a detail. So every traffic that is hitting through the firewall will have two flow. One is the client to server and the server to client flow, and you can see the respective details of the IP and the port numbers and the user details exactly on that respective flows that has been taken place for that particular session, right? If I want to verify the same info with my CLI, so what I can do is I can open up a so in the management port, I have enabled I think I have enabled the management interface with a management profile. So if I look into my device, okay, and if I look for the management interface, and I can see that my ping, HTTPS and SSH services is running, right? And this is the management IP. Okay, so since this secure shell is running, that means I can take up a putty and I can go ahead and access this particular firewall management IP using SSH. So 192.1.168.1.201 on port 22. Yep, so I accept the warning, I log in admin and supply the password which I've changed, and I can see that here I am able to log in to this particular management IP address from my management workstation using PuTTY on the management port. And if I see the same thing, we have show session info. Okay, yep, and this is, we can see the session info over here. Just a second. We have show session detail. Just a second. So when you give source session, give a question mark, so you have got multiple things, so multiple options that you can do. So you can start with source session all, and you can see that what are the active sessions that it is happening, right? So you can have the traffic type, the flag, the source port, and the basically the source socket and the destination socket, the zones information, the IP informations, etc. So you can actually see it in a detailed manner, right? And if I want to verify for a particular session in detailed manner, what I can do is I can copy this session ID, say the first one is 51, and I can see show session ID, which is 51, let's say, and I can see the session information over here, the client to server flow, the server to client flow, the application which was used, the rule which was followed, layers when processing status, the NAT rule that was followed, the ingress and the egress interface, right? So there are a lot of things that you see over here. Okay, so good. Yep, so I hope it is clear, and a lot of things upcoming. I thank you for joining. I'll see you in the next lecture. Thank you.